In the earlier parts, we learned about whenever you're trying to do a method call, the argument type can just be a descendant class of the corresponding static type of the parameter. And this is a very useful feature in order for us to create a so-called polymorphic collection. And in our case, we want to create a polymorphic collection of students, which can be either resident students or non-resident students in a single collection or a single array. That's something we want to focus on to visualize for you at the runtime. Let's now go over some slides and I'll switch to some visualization together with you. So how do you define a class student management system that consists of a resident and non-resident students? This is the question that we ask when we talk about design number 2 without the inheritance. And when we talk about design number 3 with inheritance, I promise that I'm going to revisit how we can define the student management system. And we have done so much preparation work about the foundation for substitution, typecast, polymorphism, dynamic binding, and etc. So now we can synthesize everything together into this polymorphic collection idea. Okay, let's take a look. Let's say we declare a student management system, which we spoke about, which has only a single student array. Every member, every element in the array has the static type students. Dynamically, they can be either any of the descending classes of students for substitution, right? And we got some auxiliary counter to keep track. And this is only the single method we need in order to add different kinds of students. So we can have add student method here. Statically, simply just students. So the argument type can just be a descending class of the parameter static type. And we simply just do that. Well, we spoke about in the earlier video about why this line will be valid. You can revisit there if necessary. What about register a common course for all the students in this single array? Do we need separate loops to actually do this? It turns out we don't need to. Okay, so it turns out we only need a single loop, which I will explain. We only had to say students array over here at index I, which dynamically can either be resident students or non-resident student, which I'll visualize in a moment. And we simply say register. And now let's just recall one thing. Where is the register method originally defined? According to our example, it is defined in the student class and is simply reused without being overridden in the resident student class and also in the non-resident student class. So these are the two subclasses where we can simply call register. So in order to judge whether or not this line should compile, we look at the static type for the dot notation, the context objects. It's simply students at index I. I'll try to annotate this again, but I just want to mention to you verbally, quickly. All right, it's very important for you to click on this particular link. I want you to compare and contrast. Let's do it together. If I click on this link, a collection of students without inheritance, that will bring me back to much earlier of the lecture. Okay, so this is the version where we actually got multiple arrays to store different kinds of students, right? You can see we got one array for resident students. We got another array for non-resident students. And we got so many different methods of whose parameter types would simply take either resident students or non-resident students. And also in the register all, we also need two separate loops over here. One for handling one array, the other one for handling the other array. The reason that we had to do it is because we didn't use any inheritance to introduce the hierarchy. But now, since we had it, so you can now go back to that polymorphic collection of students. So these are the two examples I really want you to compare and contrast to really appreciate. So what inheritance offers to you is not just about code reuse using the super or extend keywords. What's really deeper to it is about the polymorphism and dynamic binding, which I will illustrate to you as well. All right, so I will let you compare the two fragments of code between with inheritance and without inheritance. I'll let you do it. Okay. Let's now consider one example fragment of code, which I will switch to my iPad and illustrate to you. And then I will conclude by defining what a polymorphic collection is, which I will mention the iPad anyway. Let's now take a look. Okay. Let's now see what we have on the page. This is the example code I would like to go over with you. This is the student management system class I just went over, a single array over here. And let's now remind ourselves very quickly for the students over here. Okay, right? So here, each element has static type students at index 1, index 2, all the way to index of the length of the array -1. Students. Okay, later on we'll see why this array over here is going to be called polymorphic array. We'll see that. Okay, and also I want you to look at here for the addStudents method. You can see the parameter s has the static type students. Right, so this is also the static type, and this guy here is the parameter. And once more, you can see here we are trying to register for all the students into a common course, C. And what we do is we simply have this line of method call, right? I want to repeat the point I just said. If you look at the context objects over here, okay, if you look at what's to the left of the dot notation over here, so this part over here is the context objects with static type. Well, that's something we just said. What will be students array at index I? It should be of type students. Can we expect the register method on the students class, the static type? Indeed, we can. You can see from the student class, we do have the register method over there, as we said before. So that's why this will compile. Okay, so this compiles or valid. Compiles because it is part of the expectations of students. All right, so far, hopefully you're okay. But now here's a question I want to pose right away. But here's one question. When we actually call register over here, right? Actually, that one might be okay. You know what? Let me take it back. I don't think we need to ask this question just for now. It might be too immature. Okay. All right. So far, so good about the going over the code. And this is the runtime structure that we will eventually go into. And then I have some instance of question to ask you about whether you will evaluate to true or false. We'll get there. All right. Let's now take a look. I already drew the diagram just to save some time, but let's now take a look to see exactly how it will be built. First line. So we have resident students RS, which will be resident students, right? You can see RS over here. Dynamic type is resident students. So that is why you can see here, this part here, we got resident students. This is dynamic type of RS. Okay, dynamic type. So this is the dynamic type of RS. It's really important to see that to actually illustrate to the polymorphic collection. This is dynamic type of RS. All right. And then we also set its premium rates to be 1.5. So that's why you see 1.5 over here. And let's see the second line, the third line. We say non-resident students, NRS, non-resident students, right? So here NRS, okay, it's is going to be this objects over here. This objects over here. Okay, so this object here, you can see this part over here is the dynamic type of NRS. Okay, so this part here is dynamic type of NRS, the variable. Okay, let me emphasize again, dynamic type, you can only look at it after the new keyword over here. That's what you're going to look at. So now we basically got two variables. Dynamic types are simply just different. One is resident students, the other one is non-resident students. Okay, we set its premium rate to be 0.5 over here. All right, so far so good. And then we are creating SMS for student management system, which is over here. SMS is pointing to some student management system objects, and this part here, SS, like before, we just abbreviated for the students array, which is going to be some array of certain size. Let's say up to 100, right? That's why the last index, the biggest index will be 99. And then let's now say we want to add 2 student objects into the student management system, right? So that's something we actually said before, that this will be valid. Let's see why, quickly. So you can see RS over here is the arguments, right? RS statically is resident students over here. Okay, let me just try to use some color here, just might be easier. You can see RS has the static type resident students over here. And then we are calling the addStudents method. And can you recall what addStudent method was? Let me just write it down here. So if you recall, it looks like this. in the student management system, void add students, and then it simply declares students parameter s. Okay, so that's the method declaration. You can also refer back to your slides. Okay, so here we can see as students, and also there's a student static type for s. So when we try to call this one here, because of call by value, okay, let's now try to do that over here. Okay, so call by value. So call by value. So call by value is going to say parameter s is assigned to arguments rs. Is this valid? It is valid because rs, the arguments, was declared to be resident students, which can fulfill the expectation of the parameter s, which is declared as student type. Right? That's the detailed argument you should know how to write down, which we did earlier. And you can argue a similar way for NRS as well. So that's why we would have just added the first objects over here, our RS, into the index 0. For index 1, we're going to add this non-resident student objects. All right. So these two lines are so critical that you really want to make sure you understand. Right. Of course, the way we add objects into the array is simply following our programming pattern. We simply use the counter, like a number of students over here. Eventually, it will just be 2, right? Because we have added 2. At this point, I can now explain to you what polymorphic array, what collection really is. Okay, I want you to look at two things over here. Number one, index 0 and index 1 over here, right? So we talk about this particular students array, which was declared over here. Again, you can see over here. Students array over here, and now I'm talking about 2 specific index of that. Okay, index 0 and index 1, right? So these 2 elements, like others, what are their static type? Their static type is simply just students, as we declare over here, right? As we declare over here, like a student over here. Okay. On the other hand, what's the dynamic type for each of the elements over there? It's actually different. You can see for index 0 is actually pointing to this particular object's dynamic type is resident students over here. And for this index 1 over here, the dynamic type is actually non-resident students over here. They're different, right? So that's what we said about polymorphic collection. Polymorphic collections or polymorphic array. So what that means is over here, the static type of the members or the elements, let me say elements. The static type of elements is students, but the dynamic type of elements is simply just the descending classes of the static type students. You can see one example will be resident students, which is a static type of students. The other example is non-resident students over here, which is a descending class of students. So the dynamic type of element is simply descendants. Descendants of the static type. So that's a very important phenomenon for you to know about polymorphic collection. One thing about the static type being common for all the elements in the array, and also the dynamic type being different for every element, but they must be a descending class of the static type. Descendants of static type. Okay, so that's about the polymorphic collection part. And of course, for this course, we really require you to really build the polymorphic collection from scratch, using the primitive array. Let's now go on. And then we got the course objects, which will be 2030, 500. So that's simply just here. That one's easy. And we try to say SMS.register all. Let's now analyze this line also very carefully. Let's say this. Let's talk about this line here. So what we're saying is we're calling register all method over here. That's the method we're calling, right? And then we're going to go over the array element by elements, you can see the number of students at the moment is simply just 2. So that means we're going to go for index 0, index 1, right? So there will be 2 iterations. Okay, so I want to be very careful, so that's why I'm going to write it down. So can I just try to write down the execution for this particular for loop? I'll write it down here. Okay, so the iteration. Okay, so for the first iteration, I will be 0. So it's going to be students, I'll just say SS, right? SS array at index 0 dot register. And for the second iteration, it's going to be SS at index 1 dot register. And of course, both of them is going to register for this particular course, which is EECS2030. Okay, some course. I'll say dot dot over here. All right, let's talk about the 2 different iterations and understand what's happening here. Remember dynamic binding. The version of the method that will be invoked depends on the dynamic type. In this case, what's the dynamic type for SS0? That's very important. So you can see SS at index 0 is really referring to this object over here, right? Dynamic type is resident students. So that means it's going to invoke the version of the register method from resident students class. But if you look at the resident students class, what would be the version of the register method? Because we didn't choose to override the register method in the resident students, so we'll simply just use the version that's inherited verbatim from the student class. But for the get tuition, as we'll see later, we're gonna have some specific version to invoke in resident students, right? Okay. So that means, in conclusion, so this version over here is going to be from students, the student version, simply because, again, in the resident students class, we didn't actually choose to override the register method. That's why the only version we'll use is the default version from the register parent class, from the student parent class. All right. Similarly, if you look at the second iteration for the register R and SS1, that one there. Dynamic type is, actually, you can see index 1 is pointing to this object here, so that's non-resident students. And dynamic binding tells you the version of the register method that's going to be invoked is going to correspond to the dynamic type NRS. Do we have an overridden version for non-resident students? We don't, right? So that's why it's still going to use the inherited version register that's defined in the student class, which is okay, right? As long as there's at least one version that's available, then we are fine. All right, so that's about register all, right? So after that, you're simply just going to put the course into the corresponding array like this, right? And for adding a course into the corresponding array, that's something we have done in the previous lecture already. So I'm not gonna waste your time by going over them. All right, finally, I would like to speak about 2 more things. One is about one more instance about dynamic binding. Let's see. So here we simply go over the number of students, which will be 2, right? So this part here, number of students will just be 2. We want to go over the 2 students, and then you can see here, I specifically tell you we want to analyze the dynamic binding behavior. Let's now take a look at this one here. Student management system dot students get tuition, right? How many iterations are there going to be for this particular for loop? There should be 2 iterations, right? So let's talk about the iteration. So the iteration over here, so it will be 1 and 2. So 1 and also 2. And let me just abbreviate the students over here by using SS. Okay, so you can see SS in the diagram over here. Okay, so for the first iteration, it's going to be SMS dot array SS at index 0, and then we're gonna say get tuition. I'll say get tuition, get T. Okay, and for the second iteration, I will be value 1. So SMS, very similar to how we trace the iteration for register all. I'm just doing that once more, right? Just for completeness together with you. The SS at index 1 dot get tuition over here. So you can see index 0 and index 1. Okay. And now it's really important to know which version of the get tuition method is going to be invoked. As you can see from the diagram over here, we got 3 different versions for the get tuition. either the get tuition from the student class, which will only calculate the base amount, or we got an overridden version in the resident students, which will apply the premium rates, or we got a third version that's in the non-resident student class, which will apply the discount rate. Which version are we going to call? It depends on the dynamic type for the objects, for the context objects. Let's now take a look. You can see here, for the first iteration, you can see this context object over here, SMS dot SS index 0 is pointing to this object here. Dynamic type is resident students, right? So this part here, dynamic type is resident students. So that means the version that's going to be called for the get tuition is going to correspond to the resident students version, which will use the premium rates. Okay, so that's going to be the resident students version. Similarly, what about the next one? The next one, let me use a different color. Okay, the second iteration is going to be, looks similar. Okay, why don't I use orange? Okay, here, SMS at index 1 for the second iteration. Dynamic type for that is, you can see index 1 is really pointing to this object over here. Dynamically, it's non-resident students. So that'll be non-resident students. So that's why the get tuition method over here is going to be which version? It's going to be corresponding to the dynamic type, non-resident students version, which will invoke the discount rates. Right? It's really important for you to see that. Okay, let me put it back. So that will be the non-resident students version using discount rate. All right, so that's about a complete tracing for this fragment of code. It's really important for you to know how to trace it and also how the object structure can end up being like this, especially when I talk about polymorphic collection and also when I try to explain, especially dynamic binding for get tuition, how exactly they work. You should know that very well. Okay. Final points I would like to make is to do some instance of check, right? Let's say I'll do the first one. I'll let you do the second one by yourself. Okay. So here we're trying to do three here instance of check over here. You can see instance of over here, instance of over here, and also instance of over here, right? The left operand over there, as I mentioned to you before, it can be any expression that would denote some objects. What we had before was simply just like a reference variable, but you can definitely also use the array indexing notation, right? You can see all the left operand is simply SMS.ss at index 0. SMS.ss at index 0. So we are really referring to this particular objects over here. This objects. Okay, let me just make it maybe a little thicker over here. So that's the objects that we are talking about over here. Okay, so that's the objects. All right, for this particular objects, can we just check some instance of? So what does instance of really mean, right? Let's remind ourselves. Does the dynamic type of this let me say it again. Can the dynamic type of the left expression here fulfill the expectation of the right-hand side over here? Since this dynamic type is simply resident students, can resident students fulfill the expectation for non-resident students? It can only do if resident students is a descendant class of non-resident students, but that's not the case because they're sibling of each other. So that's why this part here would just be, the first one would just be false. Okay, remember instance of is a Boolean operator, either true or false. Second one, can the dynamic type of this, which is resident students, fulfill the expectation for resident student? Indeed, yes. The class can definitely fulfill the expectation of itself because it is a descendant class of itself. So this will be yes. So that'll be true. Next one. Can dynamic type of this, resident students, fulfill the expectation of students? Indeed, yes, because this dynamic type, resident students, is a descendant class of students. So that's why you can also do it. So that's why it's also true. All right. And as an exercise, I'm going to let you answer these three over here. So you can see the expression over here is different, right? On the left-hand side. So here I'm just trying to do on the left-hand side here using the index 1 elements, which will be this object over here. I'll let you do the exercise to see which one is true and which one is false. Right? Make sure you understand this very well. You'll definitely be asked questions later to test your understanding. All right, so that's about it. I want to that's about what I want to speak about the method parameters and also polymorphism. It's not a very difficult subject, but there are so many details you have to watch out for because you want to combine all you learned previously into what we're doing right now. All right, so next one, I would like to talk about polymorphism, how we can apply it into method return types.